It's the most wonderful time of the year, Christmas. And what better way to get into the holiday spirit than with a Minky Couture blanket? Whether you're gathered around the tree with loved ones, roasting marshmallows by the fire, or just looking for a cozy way to stay warm on a chilly night, Minky blankets are the perfect addition to your Christmas festivities. With a wide range of festive designs and colors, you can find the perfect blanket to match your holiday decor or gift to your loved ones. So this Christmas, make your holiday even cozier with a Minky Couture blanket. Head to minkycouture.com now and find your perfect blanket, just in time for the holiday. Happy holidays from Minky Couture.
Shop the Plato's Closet Black Friday event in North Charleston and West Ashley and let the deals begin. You know Plato's Closet always has a huge selection of trendy recycled styles at amazing prices, but Black Friday deals are different. They're better. We've been holding back some of our best inventory, and you won't want to miss our Black Friday event. Save on gently used styles from Patagonia, Lululemon, Lilly Pulitzer, and hundreds of popular brands. Plato's Closet is ready to let the Black Friday deals begin. Plato's Closet, located in West Ashley on Sam Rittenberg Boulevard and North Charleston on Rivers Avenue.
Good day, everybody, and welcome to the Astronomy Daily Podcast for Friday, the 4th of August, 2023. My name is Hallie, and I will be your host for today. As usual, I am in the studio with my favorite human, Tim, who unfortunately has laryngitis, so I will be doing most of the hosting duties today. As Andrew and Steve discussed Voyager 2 earlier in the week, Tim has an anecdote for us, so over to you, Tim, and no rusty voices, please.
Astronomy Daily, the podcast, with your host, Tim Gibbs.
Thanks for that, Hallie, and I'll do my very best to not sound too rusty. Now, as Hallie has already said, Steve and Andrew discussed Voyager earlier in the week. And if you do a search on YouTube for the greatest live television shot with James Burke, he is doing a live piece to camera talking about the Apollo space rockets, whilst Voyager is launching in the background. A lot of people thought this was CGI'd, but this was done in the 1970s when none of that existed. And it's really great to watch. I would recommend it to you all. Now, seeing as my voice is not 100% today, back to you, Hallie, for our stories of the week.
Thanks, Tim. In a remarkable feat of interstellar communication, NASA has successfully re-established contact with Voyager 2, a spacecraft that's been journeying through the cosmos since 1977. Currently positioned over 12.3 billion miles from Earth, Voyager 2 received an interstellar shout from NASA's highest power transmitter, based in Canberra, Australia, correcting its antenna orientation and re-establishing communication. Both Voyager spacecraft carry golden records, 12-inch gold-plated copper discs, narrating the story of our world to potential extraterrestrial life. The success of this interstellar shout, initially not expected until October 15, marks a significant milestone for NASA and the Voyager mission. However, it's worth noting that the power banks of the Voyager spacecraft are projected to run out sometime after 2025. NASA data helps Bangladeshi farmers save water, money, energy. With nearly 170 million residents, Bangladesh is one of the most densely populated nations in the world. Nearly half of its residents work on or live around farms, and rice crops are critical to feeding that population. So when researchers from the University of Washington and Bangladesh's Ministry of Agriculture joined forces to use data from NASA and its partners to help the country's rice farmers, the potential benefit was substantial. Through their IRIS program, short for the Integrated Rice Advisory System, researchers from UW and Bangladesh use satellite data to deliver information to farmers about how much water they are using, how much they have, and how much their crops need. Rice is an essential crop in Bangladesh, and cultivating it requires a lot of water and fuel. During the country's dry season, which takes place from January to June, farmers typically pump groundwater from aquifers. Pumping is expensive, and it usually requires burning fuels that release carbon dioxide into the atmosphere. To create sustainable and climate-resilient agriculture for the future, we need to minimize irrigation waste and decarbonize the production by using affordable solutions that can be scaled globally, said Faisal Hossain, professor of civil and environmental engineering at the University of Washington and leader of IRIS. The IRIS team completed its first nationwide effort in June 2023, providing advisories on irrigation needs to more than 10 million farmers across Bangladesh. Hossein and the IRIS team estimate that the program has the potential to reduce agricultural water waste in Bangladesh by about 30%, reduce agricultural fuel consumption by 45%, save $115 million annually in fuel subsidies, and reduce carbon emissions by 300,000 tons per year. An experiment sent to the International Space Station aims to help scientists develop AC for astronauts who may travel to remote areas of our solar system and perhaps one day, beyond. Deep space AC requires understanding how low gravity affects boiling and condensation. An experiment sent to the International Space Station on the final Antares rocket launch, which took place on Tuesday, August 1st, aims to help scientists develop air conditioning for a future in which astronauts can travel to remote places in the solar system. Keeping humans alive, happy and healthy while away from the comfort of Earth, including on spacecraft or in planetary habitats, will require reliable air conditioning that can continue operating in wildly different temperatures and when exposed to various gravitational environments. Heating, ventilation and air conditioning systems on Earth use evaporation and condensation to control indoor air temperatures and humidity. Thus, designing systems for possible deep space habitats will first require understanding how microgravity affects such evaporation and condensation processes. We have developed over 100 years' worth of understanding of how heat and cooling systems work in Earth's gravity, but we haven't known how they work in weightlessness, said Isam Mutawar, Purdue's Betty Ruth and Milton B. Hollander Family Professor of Mechanical Engineering, said. In a new step towards this goal, a Purdue University experiment launched on the 19th Commercial Resupply Service mission from Northrop Grumman, NG-19, to the International Space Station, ISS. Hopefully, it'll collect data to help answer long-standing questions about how boiling and condensation work in low gravity. This will add a second module to a facility called the Flow Boiling and Condensation Experiment, FBCE. The first module, aboard the ISS since August 2021, has been collecting data on the effects of microgravity on boiling in particular. But the new components arriving at ISS will soon allow teams to also investigate how condensation works in microgravity by comparing data collected in orbit with data collected on the ground. Both modules will run through 2025. Japan's XRISM X-ray Imaging and Spectroscopy Mission, pronounced a XRISM Observatory, expected to launch August 25, August 26 Japan local time, will provide an unprecedented view into some of the hottest places in the universe. And it will do so using an instrument that's actually colder than the frostiest cosmic location now known. XRISM's Resolve instrument will let us peer into the makeup of cosmic X-ray sources to a degree that hasn't been possible before, said Richard Kelly, NASA's XRISM principal investigator at NASA's Goddard Space Flight Center in Greenbelt, Maryland. We anticipate many new insights about the hottest objects in the universe, which include exploding stars, black holes and galaxies powered by them, and clusters of galaxies. A new NASA infographic illustrates the enormous range of cosmic temperatures. At the bottom of the scale is absolute 0 Kelvin, or 459.67 degrees below 0 Fahrenheit, minus 273.15 Celsius. The detector for XRISM's Resolve instrument is just a few hundredths of a degree warmer than this. It's 20 times chillier than the Boomerang Nebula, the coldest known natural environment, and about 50 times colder than the temperature of deep space, which is warmed only by the oldest light in the universe, the cosmic microwave background. The instrument, a collaboration between NASA and JAXA, Japan Aerospace Exploration Agency, must be kept so cold because it works by measuring the tiny temperature increase created when X-rays strike its detector. This information builds up a picture of how bright the source is in various X-ray energies, the equivalent of colors of visible light, and lets astronomers identify chemical elements by their unique X-ray fingerprints, called spectra. With current instruments, we're only capable of seeing these fingerprints in a comparatively blurry way, said Brian Williams, NASA's XRISM project scientist at Goddard. Resolve will effectively give X-ray astrophysics a spectrometer with a magnifying glass. XRISM's other instrument, called STEND, developed by JAXA and Japanese universities, is an X-ray imager that will perform simultaneous observations with Resolve, providing complementary information. Both instruments rely on two identical X-ray mirror assemblies developed at Goddard. The mystery surrounding a large piece of space debris that washed up on a beach in Western Australia appears to have been solved. The Australian Space Agency believes the wreckage is likely a section of the third stage of a Polar Satellite Launch Vehicle, PSLV, operated by the Indian Space Research Organisation, ISRO. The debris is thought to be part of a PSLV rocket that launched a navigation satellite for the IRNSS constellation on May 29, 2023. The incident highlights the growing problem of space debris, with the European Space Agency estimating that there are currently around 10,000 spacecraft in orbit around Earth, at least 2,000 of which are dead.
The Astronomy Daily Podcast.
Thanks for that, Hallie. Do you have a joke for us this week?
Here is a science joke for you. Why did the biologist break up with the computer scientist? Because they couldn't find a common ancestor.
Hallie, that is just a terrible joke. Thanks everybody for listening to Astronomy Daily. You can find all of our episodes, plus our parent podcast Space Nuts, at spacenuts.io or at bytes.com. And don't forget you can join in the conversation yourself by going to our Facebook page, Space Nuts Podcast Group. You can hear Steve Dunkley on Mondays and myself, Tim Gibbs, on Fridays for a full show. Thanks for listening. See you next week. Bye for now.
Thanks, Tim, TTFN.
The Astronomy Daily Podcast.
Bye.